So, a little bit about who Chanchal is, what he's been up to, and how he got here. He has a PhD. He's the cloud AI and ML at Google. So, there's something really interesting that he mentioned to me before. He received an award that was including the Outstanding Paper Award from IEEE, Neural Network Council for Adaptive Learning Algorithms, recommended by MIT and the professor Marvin Minsky. And just so you all know, this is no rookie. He has been in the game for many years beyond the amount that I can count on one hand or two hands, even. So that's why I think the knowledge that he is about to impart on all of us is going to be great. I'm excited to hear all about how to quickly deploy your ML workloads on multi clouds using Kubeflow pipelines. And without further ado, please, Chanchal, enlighten the rest of us. I'm going to jump off. I know people are real excited to have you. Thank you for being here with us, and I'll leave it to you.
Thank you very much. Can you all hear me? Awesome. Assuming everybody can hear me, perfect. Thank you. So I'm going to talk about MLOps, production, how to bring a custom AI solution onto the cloud in a simple, easy step, because a lot of us build cloud ML solutions in our desktop. We also built in on-prem solutions, and sometimes we built in one cloud and we want to make it work on another cloud. But in order to build a full scalable, secure, composable, and portable solution, you need to be in an infrastructure that supports it. So cloud is one of those infrastructures. I'm not trying to sell GCP over here or Google Cloud Platform here, but any cloud would do. So in order to make a solution work on the cloud infrastructure, it is important to have tools so that you can do that easily. And that's the part of the MLOps I'll talk about. So first is the vision. This is a project that we undertook at Google with our team. And we implemented a piece of code, which I'm going to expose at the end of it. It's an open source code, and it lets you deploy your ML model that you have built on your desktop or laptop or on-prem or other clouds, and you can port it easily. So why did we want to do this? So I already gave you a quick summary. So a ML pipeline consists of many components. So it is not an easy task to build each of them step by step by step. At the front end is the ingestion, whether you want to bring it in through a real-time interface like PubSub or any other mechanism, Rabbit. Then you can also store it in a cloud storage environment. You can also have the data in a data warehouse. But the main components of the ML are the steps after that. First of all, you have the data preparation. You need to do hyperparameter tuning, that is thousands of parameters in your ML algorithm. You need to do model training. You need to do model deployment, which means that you need to build a repository. You need to version. You need to have metadata for all the models. You need to have a proper prediction and serving platform. And you also want to have model explanation. And lastly, but not the least, is the training orchestration. How do you create the training process? How do you start the training process? How do you trigger it, whether it's user-based, it's data-based, it's time-based? So all of these different methods of training orchestration need to be done. This whole pipeline has all these components, and we need a tool in order to deploy these components seamlessly out of a model that you might have built, like a scikit-learn or XGBoost or TensorFlow model that you works very well on a bunch of data on your laptop that you want to bring into production.
Hey, sorry to
Yeah,
interrupt you real fast. Do you mind into presentation mode? We just see the first one and we can't see
you
the other
do?
slides.
Oh, really? Actually, it was in presentation mode. Can you see my slide now?
We see, yeah, I see your
So
mouse
maybe
going
I will
over.
get out of the presentation mode because the presentation mode is where I was. So let me do it this way. It's easier. Then I can also switch to the other screen where the questions are.
Okay, cool. Let me,
Okay,
yeah. So the ones, what we see right now, we see one of the windows with that's not in presentation mode, and then you have three other tabs that are open
correct.
in that window.
Yeah,
Okay,
this is the GitHub, which I'm going to talk about. This is my slide, and
yeah,
this is where all
great,
the questions are. So this is the three tabs. Thank you.
perfect. Sorry
So
to interrupt.
you can see the slide where I have the example ML pipeline with all the different components like data preparation and so on and so forth, right? Okay, so no problem. These are the different components of the ML pipeline that need to be implemented. So it should be easy to do that. If you have to write code for each of these pieces, it's a lot of work and you cannot hire enough data scientists to do that. It should be scalable, which means that as you add workloads or subtract workloads, the pipeline should go up in terms of its capabilities and go down in terms of its capabilities when you take down the number of resources, the inputs. It should be composable. Now, that's a very important piece. All these blocks should be separate, independent Docker containers so that if you decide to bypass, let's say, hyperparameter tuning, you can easily do that. If you don't want model explanation, you can take that piece out. So it should be consist of composable units so that you do not do a piece of computation that you don't want to. It should be orchestrated, which means that it should be able, you should be able to trigger this whole pipeline based on various types of inputs, whether the amount of data or the user triggers it, or you can schedule it at a certain time of the day, like 1 a.m. in the morning. It should be secure, so nobody else should be able to break into it, and it should be portable. So for example, that's a very, very important piece, and Google offers a software called Anthos in order to create a multi-cloud solution. So if you want the prediction to be running only on your cloud or a different cloud, you could take that up, or you want it to be running only on-prem. If you're a big bank, you don't want to expose all your data, then the prediction module can go on-prem, and you can keep the training mechanism on the cloud. So this is the environment where every piece can be portable, composable, scalable, should be easy to do, should be orchestrated. So there's a tall order to fulfill, but let's see what we have done if it satisfies. So our objective in building this piece of software was to automatically deploy pipeline on the Google Cloud Platform with customers or anybody's easy and quickly bring their ML models to market. We can bring the existing ML models, which means that you don't have to write this from scratch, create a scalable, composable, and secure pipeline, and demonstrate the steps for easy migration. So that's the ML task that we wanted to accomplish. So in order to do that, we built this software, which is called the ML Pipeline Generator tool, which is open source. The model you should have, or rather whether you as a third party or as a customer, should have a model with a performance that you want to achieve. It should have the necessary infrastructure on the cloud, and you should have internal technical teams and experts in order to help support the transfer. And then our success criteria is to automatically transfer the model onto the cloud and make it work. So the steps of this process is first we gather requirement, we understand your model, we identify the composable pieces, we import the data and pre-processing module, we create the pipeline, and we test the pipeline. So those are the steps. There are a few assumptions that this code will support or not support. The code will only support scikit-learn, XGBoost, and TensorFlow models. It will implement the whole model pipeline in a Kubeflow pipeline framework, which is very well known and has been open source. I'm not going to talk a whole lot about Kubeflow because Kubeflow is the basic building block for us. And it will all be done with Python. We also do not handle the data processing piece, which you will provide, and orchestration will be limited to triggers. So there are some limitations which you can, since the code is open source, you can expand on it. But basically, we support scikit-learn, XGBoost, and TensorFlow frameworks. We do not support PyTorch at this moment, for example, or Spark ML. But most of the popular ML frameworks are supported by this software. So how do we do that? So that's the next step. Is there any question at this point? Okay, no problem. Thank you very much. So how does this pipeline generation work? So going back to the end-to-end model pipeline, we have the data preparation, we have hyperparameter tuning, we have model training, we have model deployment, explanation, prediction, and orchestration. We are not going to deal with data preparation in a big way because this is a customized process that every customer has different types of data and they can take multiple different sources of data. It's very hard to find a unified method, but the rest of the components we are going to handle. So what do we mean by a component? The data processing is a component, hyperparameter tuning is a component, model training is a component, model deployment is a component. All these are individual components and will eventually become a separate Docker container and will be put together by Kubeflow pipeline. So here's the step. So you just basically go to a Git repository, which is marked in the slide deck, and I have opened it up here. This is the Git repository, which is available public GitHub, and you just download the code onto your environment. In this Git repository, you basically have a file called config.yaml. We have several examples of that in the Git. And if you're doing, let's say, scikit-learn model or an XGBoost model, you just fill in the parameters in the YAML file. Then you basically, if you have built a very complex model that is not just a scikit-learn or XGBoost or a simple TensorFlow model, if you have a very complex, like a generative adversarial network or something very complex, then you can provide the model. Otherwise, we'll build the model for you automatically. You also provide us the pre-processing code. Then we just, once the config.yaml is done, we'll run the library. Once we run the library, all the components that are described in this slide will be built. All these components will be built by that piece of code. Once that is done, then you simply put together compose this step by step in Python, all the blocks that you need. So when you run step 3, all the components will be built. In step 4, you put them together in a sequence as to what you want, what you do not want. And the entire Kubeflow pipeline will be built. The Kubeflow graph will be done for you. So everything will be done automatically. You really don't have to understand or know Kubeflow in order to do a Kubeflow-based ML deployment. That's the goal of this project. So here's an example. Let me see if there are questions. When you say user provides code, you mean the Docker image or the type task? You can just provide the simple pre-processing or the model as a Python file. You do not have to build a Docker container. You don't have to register. PyTorch is not supported at the moment. but if there is enough demand for it, we could add that into the list. We'd like to understand your needs for PyTorch, and since the code is open source, you can also contribute to the code. But sorry, not supported right now. So you can provide the .py file. I'll get to that. So here's the config.yaml. So you just fill in your project ID, you fill in where the data is coming from, you give a model name. If you want to put a custom model, then you put a model in this format as a .python file, and you just link it over here. Okay, and that's basically your filling in the config.yaml. If you do an XGBoost model, you put in what parameters you want to use, what are the parameters you want to hypertune, what are the range of values you want to hypertune. You just put it in the config.yaml file, a simple YAML file. Once you do that, then you basically run the code. Okay, once you run the code, here's the scikit-learn. It will basically ingest the config.yaml file. It will generate the pipeline, and this is the scikit-learn code that does that. This is the TensorFlow code that does that, and there is a corresponding XGBoost code that does that, and it's all there. Over here, if you go to the GitHub, you go to the examples, you can take, let's say, XGBoost. You can look at an example config file. Here is a very nice config file that we have built for you in order to test that out. You also have the demo.py. That's the Python code that I was showing you. You basically take the XGBoost template. We use the Jinja 2 framework in order to template everything. And then you just put in all the different components that you want to build. All of those will be built for you. So that's basically the idea. And the third step is to generate and link all these components together. So you can basically take the train, you can take the deploy, you can take the predict, you can take the explain, you add them all together one after another, and the Kubeflow pipeline will be created for you. So it's a very simple set of steps in order to deploy your current ML model into a scalable, secure, portable, composable framework on the cloud. Okay, so that's the whole idea, that you just simply fill in the config file, you run the library, and you put together the components of the library which you built in the previous step together. Like, these are the components, like hyperparameter tuning, model training, deployment, explanation, and so on. So you don't have to go to instantiate Kubeflow, create DSL, which is a different type of programming, and you don't have to do any of that. You simply go through this simple Python code, and all of that is done for you. So here's the GitHub location, and the GitHub location also has very good step-by-step guide. It tells you these are the 3 frameworks we use. We are currently supporting only Google Cloud Platform. And then you can, these are the steps. You basically create an account. You can do a free account, and you'll get $300 credit. That's what it used to be. I believe it's still valid. You will need to have a compute engine and a storage. Then we have a couple examples, like the New York taxi example or the loan delinquency Freddie Mac example. So basically, you bring in the examples, then you run the demonstration code, which is basically, this is step 2, and which is this step. You run the code, and all the components will be built for you. And then this is where you put the pipeline together, and you can test the pipeline. And these are all very well described over here. That's basically my talk. I would like to spend the next 10 minutes answering questions, if any. And this is a very nice solution deck. You can go in, download the code. You can, this is just a screenshot of what I have in this GitHub. And you can just try out a scikit-learn. Sometimes you don't even need to provide any modeling details. Like if you are using simple models like logistic regression, just put in the parameter, and then it will build the logistic regression model for you. You need a model file if you're building a very complex model. Let's say you did a 10-layer generative adversarial network. You cannot build that from a config file. You'll have to provide a model.py to us. If you are doing even an XGBoost model, you can just parameterize it in the config.yaml file, and it will build that for you. So sometimes you can start doing this if you have a concept of a model even, but it cannot be a very complex model. It has to be like XGBoost model or scikit-learn model or something like that. So that's my presentation, and that's the code.
Seeing a few other questions here in the chat asking about like this last one. What are the ways to trigger the pipeline? Pub, sub, or cloud functions, or any other?
Okay, so I'm just going to the question. GitHub repo, somebody. Can I go in the order that was asked?
Yeah, that's no problem.
Yeah. Our need case for PyTorch is that there is the libraries we are dependent on. Okay, I understand. So maybe you can write an email separately to me with your PyTorch need, and I can see how we can do this. I don't want to make any promises here, but I'm personally very interested in figuring out how to add PyTorch to the library. Okay. You have my contacts, I believe. We need different syntax for XGBoost and TensorFlow models. I didn't understand the question. So please rephrase the question.
That was back when you were showing one of those last slides that you had, and it was in the YAML file.
Oh, I was showing an example YAML file in the code repository.
Correct me if I'm wrong.
For XGBoost.
Or sorry if I pronounced your name incorrectly, but yeah, I think it was the YAML file that you may have showed, or on the slide that you showed.
Okay, slide had a YAML file, yes. But this is just a template showing an example, but the real details are given in the code base.
Okay, perfect.
So if you had something else in mind in this question, please rephrase it. I will answer. What are the ways to trigger the pipeline? That's a very good question. And I stated that in the assumption. Right now, we have a limited way. Orchestration will be limited to user triggers or scheduled, okay, by Kubeflow pipeline or Git triggers. These are the three ways to trigger. So you can custom user code, you can trigger it, you can schedule at a certain time of the day, or you can do Git triggers. I am personally not very familiar with this piece, but if you have some detailed questions on this, I can provide you the answers. But this is the three modes of orchestration we support. Okay. If you want more details, you can look into the code because there's the orchestration section in the code, which gives you a lot more detail. Let me, ML pipeline generation, templates, I'll have to look for it. I can do it right now. So do you specify the schedule on which DAC runs on the config? Do you specify this schedule? What happened? Okay. Schedule. No, we do not specify the schedule on which the DAC. Okay. You can schedule the pipeline but I don't think we scheduled the DAG. Is the pipeline cloud agnostic? Sorry, at this point, no. There are lots of GCP constructs in there. If you want to run it on some other cloud, you'll have to convert them to your particular cloud's APIs. So for example, we use the model, the Cloud AI platform, which is part of the Google Cloud Platform. The modeling framework is built on that. It is Dockerized. It is registered. I think we use the func to container functions that is provided by Kubeflow. So Kubeflow is the basic construct, but on top of it, all the modeling, the data preparation, the hyperparameter tuning, we call GCP APIs.
One question up above too.
Oh, yes.
From
Okay.
Edward Spencer.
So that's a very good question. Sorry, is that the TFX question?
No, but let's answer that one and then I'll ask the next one. No problem.
Okay. So the TFX is a very good question. So TFX framework is actually, we are working in close coordination with the TFX framework. All these things will eventually get merged into TFX, and you will have the ability to do the same on TFX. But that is work in progress, and there is a schedule to release it shortly, but I'm not the project manager on that. I don't know the exact timeline when they should release it. So you can use this in the meantime. When TFX is done, they will build the modules, but I think we might have to re-implement this for the TFX framework again, because TFX will not provide you this 3-button click way of implementing the pipeline to the best of my knowledge.
Very cool.
Pipeline only supports GCP, yes.
And there's a question up above from Edward Spencer. He's asking, do your data scientists, data engineers typically manage Kubeflow and config, or is it that a dedicated team, a dedicated pipeline team? So how simple does it end up being?
The Kubeflow pipeline, okay, so if your question is how does this change as the Kubeflow pipeline changes? So that's a support issue. It's a big issue for us to constantly support as the Kubeflow pipeline evolves. And that is the main reason we are merging a lot of this code into the TFX work, because the pipeline and the evolution of the Kubeflow pipeline. So we do not expect the Kubeflow pipeline to change in a big way between now and when this will eventually all be a part of TFX. Monitoring capability, actually that's a very good one. The TensorBoard-based visualization is not part of the code right now, but we can easily add those things. So put that in the suggestion, or even better, if you could add that into the open source code, then we'd love to have your contribution.
Get out there and start coding.
Yeah. Yeah, or let us know what you want. I mean, the PyTorch is the one I sympathize the most. I think we should add that, but I only had limited budget and a limited team to implement this. So at least we got it out of the door, and to help people deploy their models onto the cloud. So that's all I have.
I have one last question, unless somebody else throws up another question in there. If I want to go and I want to sell this to my team that I'm working with on why this is a better use than, say, Kubeflow or using like Kale and Rock, what are these main advantages that you see?
Oh, yeah. So Kubeflow pipeline is like a basis, right? is like the surface on which you build the house. It's a lot of work in order to create the containers. The whole reason we did this project is because last year I went through a project in which I built the Kubeflow pipeline and from scratch, and it took me several hours, if not days, to do it. And I said, I don't want anybody else to go through this experience again. So we put a team together in order to implement so that you can do it in this 4-button clicks and the whole pipeline is done. If you want to do it from Kubeflow pipeline, you'll have to build your own modules, all these different modules from scratch. Okay, you have to individually test them. Then you'll have to create containers out of that. You have to register the containers. Then Kubeflow provides a DSL-like language in order to build the whole pipeline. They're changing that, but it still exists. Then you have to create this whole process. None of that needs to be done here. And now if you, in order to do a scikit-learn model, you have to do all that testing, everything separately. So forget all that. This is very simple. You don't even have to know Kubeflow to make this work on Kubeflow.
Well, that is a great way to finish this up. I want to say big thank you for this talk. Unless anyone has any other questions, we're going to go ahead and wrap it up. This has been great, and I learned something new. I'm going to go and have a little play with the open source code. And what? Oh, here we go. One last question. What is the name of this package?
It is called ML Pipeline Generator Python. I mean, Google has the process of giving the name, the task, and the language. So that's how it is. It's github.com, Google Cloud Platform. This whole link, if you can copy it down, or it's linked in my slide deck, which I'll be happy to share.
Yeah, there is in the chat in case anyone wants to go and have a play. Thank you so much.
Oh yeah, that's a good way to correct. So I'll add it again.
Great. Well, this has been very insightful, and I am gonna go see how much fun I can have with this. I'm sure everyone else is.
Awesome.
Thank you for chatting with us, and have a great day.
Thank you.
Bye, everyone.
Thank you very much.
Thanks for listening in.
Bye.